Jai Hind to all. I am Updesh Kumar Jaiswal, working as an assistant professor in Department of Computer Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss about the topic run length, zero blank, LZ77, LZ78, LZW data compression techniques, and it is related to the subject data encryption and compression STCS 501 BTech 5th semester subject in the AKTU. So firstly I want to give the introduction of data compression. Data compression reduces the size of a data file like text, image, video, audio for storage or transmission. Compression are basically two types, lossless compression and lossy compression. In lossless compression, no data is lost during compression, making it ideal for application where exact data recovery is required at the receiver side, such as text file, images, where quality preservation is very important. So in lossless compression, original data can be perfectly reconstructed from the compressed data without any loss of information. Below I have written the three lossless compression techniques: run length encoding, zero blank encoding, LZ77, LZ78 and LZW data compression test technique series. So these three are basically the lossless data compression technique, and these are very popular nowadays. Now run length encoding. It is a simple and effective data compression algorithm used to present sequences with repeating elements in a compact form. It is basically used for data with many consecutive repeated values, such as images with large area of uniform colon or text with repeating characters. Working of length run length encoding. The basic idea is to replace sequence of the same data value with a single instance of data followed by the count of its repetition. This reduces the size of the data by eliminating the redundancy. For example, suppose I had taken the data A triple B 2 times C D double A. This is the input data. So according to run length encoding, here A is repeated 4 times. 1, 2, 3, 4 times. So it becomes 4A. So its reduced form will be 4A, means A is repeated 4 times. Similarly, B is repeated 3 times, so it becomes 3B. C is repeated 2 times, so it becomes 2C, and D came only 1 time, so it is 1D, and A came 2 times, so it becomes the 2A. So after combining these three, we will get the output data, that is the compressed data 4A, 3B, 2C, 1D, 2A. So we can say the size is reduced now. So what are the advantages of RLE? It is very simple, efficient and lossless. But there are always some negative side also. So disadvantages are, limitations are inefficiency with random data, limited use cases. Application of RLE is image compression, in text compression, in genomic sequences and telecommunication. Now another lossless compression technique is the zero blank encoding. It is a specialized data compression technique aimed at efficiently encoding sequences of zero or blank values. Spaces in text are zero. So if in text spaces are coming or zero are coming, both are like similar. In numeric data, concept of zero blank encoding. Instead of storing each zero or blank explicitly, the algorithm replaces consecutive sequences of these values with a shorter representation. I will show it with a help of example. Typically, this involves storing the number of consecutive zero or blanks and a marker indicating that start of such a sequence. I have given one example here. The input data is 1, then 0 is written 8 times, 5, then 0 is written 3 times, 7, then 0 is written 3 times. So output data, that is the compressed data, will be starting point for this 1, it is indicating the starting point. After that there are 8 0, so it is represented by 8 0, means Z means 0, then 5 followed by 3 0, so 5 Z3, 7 followed by 3 0, so 7 Z3. So here 1 Z8 represents the digit 1 followed by 8 0, 5 Z3 represents the digit 5 followed by 3 0, and 7 Z3 represents the digit 7 followed by 3 0. So this input data after compression will be this, and clearly the size is reduced here. Now introduction to Lempel-G algorithms. The Lempel-G algorithm, specifically LZ77 and LZ78, were developed by Abraham Lempel and Jacob G in 1977 and 1978 respectively. It was developed in 1977, so its name becomes the LZ77, and in 78 it was developed, so it became LZ78. While working in Israel Institute of Technology, they use dictionary based compression technique that replaces repeated sequence with references. I will discuss these three: LZ77, LZW8 and LZW one by one. So starting from the LZ77 encoding, it is a lossless data compression algorithm introduced by Abraham Lempel, as I already told, Jacob G in 1977. LZ77 is a dictionary based compression technique that replaces repeated occurrence of data with references to a single copy stored earlier in the data stream. LZ77 encoding uses a sliding window to replace repeated substring with references. So here I am showing the sliding window. This is the surge buffer and this is the look ahead buffer, and one pointer is placed here showing the starting of the surge buffer. How it's work I am going to explain. LZ77 uses a sliding window approach to encode repeated sequence efficiently. The algorithm operates as follow: sliding window. This is the sliding window. It maintains a surge buffer, here surge buffer, then look ahead buffer. So it maintains a surge buffer, store previously seen data, and a look ahead buffer, store upcoming data to be processed. The surge buffer acts as a dictionary for finding repeated patterns. Now second step is the encoding process. The encoder scans the look ahead buffer to find the longest match with the surge buffer. So here longest match, firstly A match, then longest match A B C D up to here. This is the longest match in the given example. Then if a match is found, it is replaced with a triple, that is called having the three values: offset, length and next character. So what is offset? Distance from the current position to the matching sequence in the surge buffer. Length is the number of character in the matching sequence. Here 4 characters are matching. And the next character, the character after the match, works well with pattern in text and binary data, used in many compression schemes like zip file, gzip, png. LZ70 encoding came into the feature. It is also a dictionary based lossless data compression technique and developed in 1978. Unlike LZ77, LZ78 uses a sliding window. LZ78 uses a dynamic dictionary of substring during compression. So now I am going to give the decoding process. Example, decoding is the reverse of encoding. So we can say here at the receiver side, output phrase is obtained like this. So 0 comma W, 0 represent W came first time, so it represent single occurrence. So W is written here, then 0y, y as asterisk. Now 1 comma y. So 1 is showing this thing, and equivalent to W. So in place of 1, W will come W and the next character WY. 0 comma G. Now 5 comma S. So at the fifth position 5 WY is coming. So in place of 5 we will write the WYS and so on. So this is the decoding scheme and we will get the original message. Advantages of LZ78: better dictionary utilization, faster encoding and decoding, adaptive and dynamic, efficient for symbolic data, foundation for LJW compression technique, which I will discuss in the next PPT. Dictionary overhead, these are the disadvantages: inefficiency for small files, redundant entries in dictionary, less effective for random or non-repetitive data, fixed dictionary size issue. These are the disadvantages. Now, after the LJ78, LJW encoding came into the feature, and it is the improved version of LZ78 that removes the need to transmit dictionary entry explicitly. There is no need to send the dictionary explicitly with the adding in the original message. The Lempel G. Welch algorithm was developed in 1984 by Abraham Lempel, Jacob, and a new scientist is added that is called as the Terry Welch. Due to his name, the encoding is known as the LJW. It was developed while they were working at the Xerox Corporation, Palo Alto Research Center, Park in California, USA. LJW is the compression technique used in GIF, graphics interchange format, used for simple graphics and web animation, etc. And TIF, tagged image file format, used for scanning photography, desktop publication, etc. Now I am going to give one example of LJW encoding. Encoding generally performed at the sender side. Suppose we have to compress this text message WIS asterisk WISG WIS asterisk WIS WISG using the LJW technique. In this, already a dictionary exists having the 255 characters. So 255 index are already engaged. Suppose the first symbol, that is the W, then encoder output will be 63 because it is already placed in the dictionary at the 63 placed. So now after W another symbol is Y. So after W Y will come. Here we will write 63, that is the WY, and the new entry will be at the 256th position. Now Y will come, it is at the 65th position. After Y, S is coming, so we will write YS and it will come at the 257 index. Then S, so it is at the 59 index, it is already given. So S asterisk So addition to dictionary will be at the 258 position, and so on. And finally, end of the text, end of the scanning will be occurred. So this data is sent at the receiver side. We can say this is the compressed data, encrypted data, and at the receiver side decoding, that is the decryption is performed. So here 63, 65, 59, 63 represent W. So at the dictionary position, we will start from here because we require at least two elements, W and Y. So W at the 63 position and Y at the 65 position. So WY will be new entry, and as a receiver knows that 255 index are already engaged, so it was placed at the 256. Then S, YS and 256 and so on. So we will get the original message at the receiver side using this decoding technique, that is the LJW decoding. So now I am going to discuss the applications of different methods which I have discussed today. Run length encoding, RLE, zero blank encoding, LZ77, LZ78 and LZW. So what are the application? For RLE, image formats like BMP and TIFF where large area of a single color or pattern occur. Zero blank encoding, sparse data such as bitmap images with large blank areas, compression of large matrices with many zero values. LZ77 is used in the large data set, zip file format, HTTP. File system like NTFS exists. For LZ78, it is used in the data storage system like ARC, PKZip and GIP format. And LZW, it is used in case of GIF, TIF, FEP, Unix and PostScript. Now, comparison of different compression method on the basis of attributes like strength, compression ratio, complexity, speed, dictionary management. In case of RLE, means run length encoding, it is simple, effective for repeated data. For zero blank encoding, it is efficient for zero having data. For LZ77, handles large data set with repetitive patterns. LZ78, faster lookup, dynamic dictionary construction. LZW, non-predefined dictionary adopts dynamically. Compression ratio, moderate for repetitive data, moderate, higher for repeated data, higher for repeated data and higher for repeated data. Complexity, low, low, high, moderate, more complex than LZ77 and LZ7. Speed, fast, compression, slower compression, fast especially for sparse data, moderate, faster and moderate. Dictionary management, no dictionary needed. It is important point to be noted. No dictionary, just zero tracking. Sliding window, external dictionary. In case of LZ77, sliding window is used, which I have already discussed. In case of LZ78, dynamic dictionary construction, and in case of LZW, dynamic dictionary, no initial setup is required. So these are the main comparison between these lossless techniques, compression techniques. These are the references which I have used to make this lecture. Thank you and Jai Hind to all.